In this section, we'll be writing the equation of a function in slope-intercept form. So let's say we have a function somewhere out in the world, and the slope of this function, the slope of this line is m equals 2. So our slope is 2, and we're also told that f of 1 equals 4. Now f of 1, all that means is we have f of x, and we plugged in 1 for x. So what this means in this particular example is x equals 1 and then y equals 4. Okay, we're actually given the slope of a line or function as well as a function evaluated for a particular value of x. Though this is what evaluating a function looks like, let's not get confused. F of x essentially equals, it's the same thing as y. These terms are interchangeable, and f of 1 equals 4, which simply tells us that we have the point 1, 4. Because we plugged in 1 for x, and since f of x equals y, we can say y equals 4 when x equals 1. This is actually the cool part in our course where we make the transition from using y to using the functional notation of f of x. And that's because it gives us a lot more information. We can see where the independent variable is and where and it just eliminates the guesswork of which is the dependent and independent variables. That being said, we're told that the slope is m equals 2 and the line contains the point 1, 4. Well, we already know how to write an equation using the slope of a line and a point. And we can do it in slope-intercept form, but instead we're going to use functional notation this time. So let's go ahead and do that. So slope-intercept form again is y equals mx plus b. So let's say slope-intercept form is f of x equals mx plus b. Okay, this is the functional notation of a slope-intercept form of a line. So let's go ahead and plug in what we know, and we know that we need a y-intercept. We need to solve for b. So we have y right here and x right here. And one more thing, we can actually write this, if you want to, as x, the coordinate, and f of x instead of the y coordinate, because it's where our function is evaluated when x equals some number. Okay, so we can also write it like this for functional notation, but for now, we know f of x or y is 4 equals mx, m is 2, and x is 1, plus b. And just like before, we simply solve for b. It's the y value of our x and of our y-intercept, excuse me. So we have 4 equals 2 times 1 is 2, plus b. If we subtract 2 from both sides, we get b equals 2. And now we can write the general form of our equation. Only this time we're going to write it in functional notation. So we're going to say f of x equals 2x plus b, and b equals 2. So f of x equals 2x plus 2 is our slope-intercept form of our equation written in functional notation. Okay, so this is really important, especially if you plan on taking any math higher than algebra. You're going to be using functions quite extensively, and when you get into calculus and further, we actually use it exclusively. So just get familiar with it. It's nothing fancy. We're just substituting f of x in for y. It's just a change of notation. And it's actually going to help out and clarify things much better once we get familiar with it. So let's look at another one. Let's say we're given the slope of a line. The slope is -5, and we're also told that f of -3 equals 4. Well, we know that this is x equals -3, and we can say f of x, when it's evaluated at -3, is 4. Remember, this is the same thing as y. Okay, so let's not get confused here. So let's simply write our slope-intercept form. We're going to need our b, our y-intercept. So let's go ahead and solve for that. So we have 4 equals mx plus b, so we have -5 times x, which is a -3, plus b. b is what we want to solve for. So we have 4 equals minus 5 times minus 3 is a positive 15. If we subtract 15 from both sides, we get b equals minus 11. And now we can write the general form. So we have f of x equals minus 5x plus b. b is negative, so negative 11, minus 11. So this is our slope-intercept form of the equation of a line, just written in functional notation. Let's do a few more just so we can get really comfortable with this. Let's say we have a line that has a slope of 1/2, and the function is evaluated at 7, and it's equal to 0. So f of 7 is how this is read. F of 7 equals 0. All right, so we know that we have a line going through the point x equals 7. That's all of f of 7 means, is we're plugging in 7 for x, and y equals 0 when we do that. When we plug in 7 for x, our function spits out 0. So we know that our line goes through the point 7, 0. So let's go ahead and find our y-intercept so we can write the general equation. So we have y, or f of x, equals 0. So 0 equals 1/2 times x, which is 7, plus b. Not a whole lot to it. We should be really familiar with this part of it. 0 equals 7 times 1/2 is just 7/2, plus b, and we subtract 7/2 from both sides. We get b equals minus 7/2, and then we can write our general form equation in slope-intercept form using functional notation. So f of x instead of y equals mx plus b. M is 1/2 times x plus b, which b is negative, so minus 7/2. And that's all there is to it. Okay, so we're not using any magic here. We're just taking what we know, and we're just changing some notation, and everything just works pretty much the same way. Let's squeeze in another one down here. Let's say we have the equation of a line, or a function, has a slope of minus 1.5. And we're told that f of 0 equals minus 5. So we know that from this piece of information that our function goes through the point 0, minus 5, because our coordinate is made up of x and f of x. Okay, so 0 and minus 5, we want to find our y-intercept so we can write the general equation in slope-intercept form, just using functional notation. That's the only difference here. So we can say f of x, which is minus 5, equals, let's go ahead and convert minus 1.5 into a fraction because I don't like dealing with decimals. So this will give us a minus 3 over 2. It's the same thing as minus 1.5. So m times x, so m is minus 3 over 2 times x, which is 0, plus b. We want to solve for b, so let's go ahead and do so. We have minus 5 equals, this time 0 just cancels, so we have b on the other side. So b equals minus 5, and now we're ready to write our general equation. So we have f of x equals mx plus b. So we have m is minus 3/2 times x plus b. b is negative, so we have minus 5. All right, it's fairly simple. We're just trying to get familiar and a little comfortable with using the functional notation. Everything else works the same, but you can start to see the usefulness of having a function using this functional notation. So we'll, this one we used a slope and the function evaluated at a given point to write the equation of the function in slope-intercept form. Now, in the next section, we'll be using just two, we won't be given the slope, but we'll be given 2 places where the function will be evaluated for a given value. And we'll find the equation of the function in slope-intercept form using those 2 pieces of information. So that's coming up, and I'll see you soon.